So this is a function of this is an example of a multiplexer in which we have to write a Boolean function in the form implement a Boolean function using a multiplexer. So the question is, consider the function f2 in the form x dot y plus x dot z plus y dot z and implement f2 using a multiplexer. Now to implement this function, this Boolean function using a multiplexer, first we have to write this expression in its standard sum of product form. So to write the standard form of sum of products, uh, we have to see what variable is missing in the expression. So this function contains three variables x, y, and z. It is a function of three variables. So in the first part of this expression, there is x and y. So z is missing in the first part. In the second part, there is x dot z and z is missing. And in the third part, there is y dot z and here x is missing. So to add the missing term and write it in the standard form, we will multiply or dot it with the addition of that variable with its complement. So for example, here in the first part z was missing, so we have multiplied it with the z plus z complement, and in the second part we have multiplied it with y with plus y complement, and the third part x plus x complement. And after simplification and the applying the distribution on x and y and z plus z complement and z, we will get this expression here. Now in the all the expressions contains all the three variables x, y, and z in the complemented and non-complemented form. After further simplification, we will achieve the final form of sum of product as this expression. This is the final sum of product form. In its previous part there was x, y, z that is coming three times, and there was addition oriented, and so after adding it, it is represented as a single expression here. So this is the standard form of the function f2. Now we have to write this standard form of function as the minimum terms. So what are the min terms involved in this expression? In the sum of product, we take the variable value to be 1. So in the first part, if the variable x is taken as 1, it is complemented, so its value comes out to be 0. And y is not complemented, so y remains 1 and z remains 1. So the first part shows 0, 1, 1. And this binary 0, 1, 1 is equals to 3 in the decimal form. Similarly, the second part is 1, 0, 1 because y is complemented, so y comes out to be 0, where x and z remains 1, and this binary is converted to decimal form, which is decimal equivalent is 5. Similarly, third part is x, y, z complement. It represents 1, 1, 0, and it is equals to 6, and 1, 1, 1 last part, which is equals to 7. Now what we have done so far is that we have converted this given function f2 in the standard form and wrote its minimum terms. The min terms are 3, 5, 6, and 7. Now we have to represent these min terms as by using a multiplexer. For that, we have to choose what multiplexer is used. There are various multiplexers, and that depends upon the input and their outputs. So if we are using we are given three variables, then it depends on the number of variables that what type of multiplexer is used. So if in this expression f2, the f2 contains three variables. These are x, y, and z. So for that purpose, in a multiplexer we have, for example, if we have a 4 by 1 multiplexer, So there are four inputs and one output. So it depends on the number of variables. We are given three variables. So in that case, if we are using 4 by 1 multiplexer, then we have to use these two variables as the selection lines, whereas the third variable is used uh, as the input in the multiplexer. So for this reason, we have to use the Karnaugh map. Uh, in the Karnaugh map, first we write the third variable form, that what the third variable represents. So here in this case, I'm considering that X represents the first selection line. So this is, for example, S0, and Y represents the second selection line, S1, and Z represents the input, that is what type of input is given to it, that it could be I0, I1, I2, or I3. So here I will be using a 4 by 1 multiplexer, because it contains three variables and two are used as selection lines. So the multiplexer depends on the number of selection lines. If we have n selection lines, then it represents 2 to the power n inputs, and if the selection lines are 2, then the input variables will be 4. So it should be a 4 by 1 multiplexer. For that, since we have X and Y as selection lines, and these X and Y are taken as its values are taken to be as 0 or 1. So there are, for the two variables, uh, there are four conditions: 0 0, 0 1, 1 0, and 1 1. Now the third, Z, which is considered as input, it should be used when we are using a multiplexer, that what input should be given to that function. So in this case, for the simplification, I will be using the Karnaugh map. It is in this Karnaugh map there are three variables, X, Y, and Z. So in our function, the min terms that are appearing are 3, 5, 6, and 7. These were the these were the min terms that appeared in this function when we have converted it into a standard form. Now for these values, what will be the function form of these variables X, Y, and Z? So for the first part, that is when we are having the value of 3 as the min term, the output, so we will consider this part of the Carter map, and here the function value X and Y is 0 and 1. So X has value X complement, Y is without complement because Y has value 1, and the value of Z for that 3 is 1. So it is x complement y z. The second is the second part is the first part has value x complement y and z for this 3. Now for the value 5, the expression comes out to be x y complement, and z has value again 1. Then after 3, 5, we were having value 6 and 7. For 6, the expression has the new form x, y, and its z value is 0. So it should be a z complement. Similarly, for the last value 7, for 7, we are having x and y 1, 1. So x and y and z is also 1. So these are the functions that form from the minterms. For the first minterm x complement y z, second for 5 x y complement z, for 6 x y z complement, and for 7 x y and z. Now we have to implement this function using a multiplexer. So in the since we have written these outputs in the form of these expressions, now the output is x not y x complement y z is equals to I0. We are using a 4 by 1 multiplexer, and it has these two are its selection lines. Uh, and the selection lines are given the variables x and y. These are the selection lines, and the third variable z will be used as an input here, and we will get the output according to the minterms that were given in the function f2. Now the first minterm, which is represented by this x complement and yz, which is equals to 3, and the second was 5. Then we were having 6 and 7. Now what we'll be doing is that since we have used these two selection lines as x and y variables, and the third variable z is applied as a input here. Now in these outputs, I note has the value of z, and I1 has also value of z, and I2 has z complement, whereas I3 has value of z. So what we'll be doing is that we will be giving these values inputs value of z from here. So it is joined with z. Similarly, I1 is joined with z, and I2 and I3. Now in the expression, the I2 value contains z complement. So for that purpose, we will attach a not with this I2 part, so that here the input is given as the complement. Now, according to these inputs, we will get the output from the this 4 by 1 multiplexer, and the output will be these I0, I1, I2, and I3. So in this example, we have given a function, Boolean function, which we have to represent using a implement using a multiplexer. And to implement the multiplexer, first we have to convert it into a standard form of products, and then write its min terms. And if there are, it depends on the number of variables for the multiplexer to be used. If there are three variables, then we will be using a 4 by 1 multiplexer. From these three variables, two are used as selection inputs, and one third variable is attached with the inputs of the multiplexer. And similarly, if we are given a function of four variables, then we use three as the selection inputs, which gives 2 power 3, that is 8 inputs, and the fourth variable will be attached to the inputs to complete the implementation of multiplexer circuit.